Okay, in this last video, we're going to find a best fitting model for a new set of data. So in the last video, we looked at the average price to go to a private school over the last 12, 13 years or so. Now we're going to look at the gas mileage of a particular car based on its speed. So comparing the speed of the car in miles per hour and the average fuel efficiency in miles per gallon. We're going to use a graphing calculator to find a model for the data, like I said. So I've got the data already entered onto the calculator. If I go to Stat, Edit, and you can enter your list. I put mine in list 3 and list 4. Remember, to clear a list, you hit the up arrow, hit clear on the title, and hit enter, and it'll take care of that. But here I've got the two sets of numbers, the speeds and then the corresponding gas mileage that you get. In order to find a model, first I need to know what kind of model it is that I'm looking for. So I'm going to go to my scatter plot. I'll leave that out. I'm going to change the X list to list 3 and the Y list to list 4. Oops, not 4, but second 4 to get L4. Here we go. And graph it and probably be disappointed. There's a line from the last example. There's no data points. So we're going to go ahead and go to Y equals. Clear out the line that is currently graphed and then zoom to our statistics. Zoom 9 will zoom stat. And enter. Well, there's my data. I notice that it goes up and then at some point starts to come back down. I would imagine that if I were to go 70, 80, 90 miles an hour, we'd probably not get great gas mileage and probably be even less. So this looks to me like a parabola, which says this is probably a quadratic model. And if that's the case, I can find the best fitting quadratic model by calculating the quadratic regression for that set of data. So again, I need to change my X list to list 3 and my Y list to list 4 to make sure that it matches where I put my data. I will store this regression equation as function y1, just like I did with the last example. And when I'm ready, I will calculate it. So spits out some numbers here for me. I'm going to jot these down. So my answer that I would write down would be y equals negative 0.0079, we'll say, we'll round it there, x squared plus b is 0.726, that's 0.72669, oh boy, we missed the rounding, it's okay, times x plus c, my constant at the end, is 13.756. So kind of written ugly, but you get the idea. Here's the numbers there. That's A, B, and C. That's what it looks like as a quadratic model. Last thing I'll do is I'll check my model to see how well it fit by hitting graph. And because I stored my regression equation as function y1, I should see a nice parabola. That's pretty good, fairly accurate fitting that set of data. So that's choosing the best model for two variable data.